So we're the 2014 Texas A&M Formula SAE team. What Formula SAE is, we build a small Formula-style race car, open-wheel racing. It's our senior design project for many of us mechanical engineers. We also have aerospace engineers on our team. We have mechanical and manufacturing engineers on our team. What the goal of the competition is to just completely design and build that race car to go to the competition in Lincoln, Nebraska for us on June 19th. There's design points for like, why did you use carbon fiber here? Why did you choose this spring? Why did you use a two-frame chassis rather than a carbon fiber chassis? Just explaining the design of it. And then there's also, of course, racing points for how fast does your car go in like a acceleration event? How fast is it doing autocross going around, turning quickly? It's a lot of turning more than just flat out straightaways or ovals like NASCAR. It's more like Formula Series racing where you're just doing a lot of S-turns.
Chassis group in particular, we're actually responsible for building the entire chassis and also facilitating all the other groups and also making sure that the driver is comfortable. Something that we kind of faced, like a challenge that we faced, is we actually went through and we had a big kind of internal struggle in the beginning in the fall semester where we were designing the chassis, because we were really bouncing back and forth between using a carbon fiber monocoque chassis or the steel tube space frame chassis. And so eventually we decided to go with a steel tube space frame. And here recently it's become apparent that we were very wise in that choice, because we've had to make significant and varied and many modifications to the chassis. And so it's really nice being able to, cut and grind on a steel tube chassis, bend up some new tube, put it in there, tack it, fully weld it, and get out the door again.
This year I'm the Powertrain group leader. Basically, Powertrain, we combine engine and drivetrain teams, so we deal with everything from power generation to transmission and torque through the axles. So this year we came up with a basically lightweight, kind of reliable, simple combination of factors. We built a big bore, high compression WR450F. It's a Yamaha. We ended up reverting back to a naturally aspirated setup, and it's worked out for us because we're back on time and getting our engine on, and it runs really well. So luckily, we're back on track with that.
I don't know of anyone on this team who this hasn't been a factor, if not the biggest factor, in them getting their internships, their job opportunities. For me, grad school, for multiples of us, grad school, just because everything we've done so far is great, but it's largely theoretical, and it was all a culmination waiting for this sort of thing to manifest it. And this is just a premier project, in which case you put all of that theory into practice, things that you didn't actually know really would have an application later on turn out to have a very important sort of way that they apply to this vehicle.
I've been told by many companies that they like people who do Formula SAE because no matter where they go, they know the Formula people work really hard, probably one of the most intricate engineering projects at any university.
By far, this is the most important and best course that I've ever taken at A&M.